So friends, the previous lecture was on sensors, okay, and of course we have talked about data acquisition system even in earlier lectures also. This has been a common thread running across all the lectures and maybe subsequent lectures also. This particular lecture is dedicated to data acquisition system. So we know that data acquisition system is the key component of the prognostics and health management of hardware component. What happens basically is we want to we had signal from the sensor, okay, and assume that those signals are optimized and balanced and they fit our requirement. Then the second question comes is whether transducer is part of the data acquisition system or it is a part independent entity or it is a part of sensor itself. Okay. So once we know that okay, our transducer has given us a quality signal. I'll use this word in terms of its accuracy, in terms of its sensitivity and other parameters, that metrics we have discussed in the previous lecture. Okay. So now these signals they are fed to, now what are the signals? These are the electrical signals, and they are electrical signals and they are fed from the sensor, as I mentioned, and transducer to let us say signal conditioning card. It is again a electronic device. In fact, often softwares are also used for signal conditioning actually, and there we see in fact signal conditioning has been almost like a 3-decade old system, but sometimes we can call it as if you are amplifying the signal, we call it as amplifier also or normalize also. So different terms are used. We use the term as on today, it is a signal conditioning. That means we are trying to have the intensity of the signal in such a way that it is fitting our data acquisition system requirement. Of course, signal conditioning is part of the data for further processes also, you know. So signal conditioning has happened, the signal has been brought down or amplified, whatever it was required, and then it is fed to the ADC card, that is analog to digital card. These things have been discussed, we have done, and then fed to analog to digital converter. Okay. So once this happens, the output will be digital here, okay, and output of ADC will be digital, input will be analog. So now we got a digital signal with us. Now if you see at the level of plant, there will be many components that you would like to monitor. So signal will not be one, there will be many digital signals that you are getting from the plant. Okay, for every signal has to go through the ADC and get a digital signal. So how to do that? The multiplexer is a critical component for that. It takes all the inputs and then produces output. How? If there are more than one sensor, transducer, data transmission, then feed the same to multiplexer module such that more than one digital stream for F data management is also there, and further it goes to data representation. Okay. So that means we are having more than one, and how they are discharged from the multiplexer, there is also a sequence from there, softwares are built around that. So we have multiplexer, multiple input and multiple output will be generated. From PHM purposes, the data is fed to machine learning module for training and learning. That is again intelligent domain. So, from input sensor data, data acquisition system, this 3 stages of processing from sensor onwards, and then finally going to the application, that is in our case it is machine learning application. Now, before we go ahead and we will see the metrics for sensor selection, you know, for data acquisition system. So, what is the first matrix? Number of signals and thereby requirement of channel in DAQ. We should select a data acquisition system. Like suppose if I got a vibration and temperature, and one I'll not be using all through only 2 signals. I might use 3 more signals. So, I will go for a 5 channel data acquisition system or 10 channel data acquisition system. So that in future this capacity should not limit my use of DAQ in the plant. Then type of data, analog or digital. If I already have in my plant digital data coming in, then analog D to A converter is not required. You know, or I can have both data, analog data also, and that is a normal case actually. Many data they come in the form of analog signal, and many data they come in the, so the kind of treatment differs. So all analog data will have to go through ADC, and then the digital data in the required format can go for any application, you know. Then type of the data acquisition system, then accuracy and time constant. We saw I think 7 or 10 characteristic. So accuracy is one of the characteristic, and which is very important for any application. And as far as the time constant is concerned, what is the rate at which we want the information? Like analog, if we have 1 per second, in digital it will be 8 per second actually. It should be, you know. So analog to digital conversion requirement is there or not, that we got from here. Requirement of multiplexer is again one more input, output format and frequency. What is the output we require actually, you know. So that will depend on multiple output, one output, digital, analog, and there will be one module, output module, which will be catering to all the output requirements. Because you know that now everything is done in an integrated manner. It is not that each output will be going separately, it will be coming onto the output module. Level of precision at the output, what kind of precision, accuracy, sensitivity we require at the output, that complete stream. Sometimes somebody might say I need only accuracy, okay. So far it is okay, but if you require resolution also, then you have to look for those kind of qualities which are coming in the output. So we said 8 seconds, somebody can say no, it should be more than that. My application is in a very you know, fast evolving scenario. So we might go this time constant, but again it is limited by instrument's capability. Then based on expectation of the return on investment and additional input, the resource allocated to DAQ. So the point here we are communicating it is, at the end of the day, even though safety is an overriding factor, plant availability is overriding factor, but at maintenance level these things have to be optimized so that our job is not compromised, but at the same time we are not spending, that is return on investment is also optimized actually. So as I had mentioned, I will be discussing this figure in different context, you know. So let us say now I am dedicating this lecture to data acquisition system. So we have a plant, I am showing only one sensor. In fact, if it is a reactor, all around this sensors will be kept, and thousands of the, hundreds of the, or tens of the sensors will be available. And if the signal is not in the required format, then I have to use a transducer, as I mentioned. So electrical signal analog output is there from here, and then signal conditioning I will do before I feed it to actually this is second time it has come, signal conditioning module. Okay, so we can ignore this actually. Okay, Now signal conditioning module is there, and now if I want to collect any analog data or signal from the plant required to the plant, so that is, I got analog output, and then at the output of this we can, if we ignore it, again I can use analog output also in the plant for some applications. Okay. But if I want only digital, then I got digital output, D2A converter is giving me. Okay. And then we have multiplexer, many inputs are coming in. So we have a digital bus and we have an analog bus, and these are the requirement of the prognostics, and they can be utilized. If I can manage with only analog data, it is good. If I have to convert it to digital, it is to come through the multiplexer, and multiplexer has got its own way of operation. I will be discussing in the subsequent slide, because this is what this lecture, this particular lecture is meant for it. So we saw all the major components of the data acquisition system here, and how they are integrated in the plant. We are tapped from the plant these inputs, and they got converted and fed into the plant. Now it depends on, for us it is a PHM implementation that we can say, but we are not giving the detail. It is not required also for this lecture. Now the first item was, if we leave the sensor, it was the transducer. So under the head of data acquisition system, we are discussing what is a transducer. Transducer, we know that it takes any mechanical signal or any pneumatic signal, and it provides the electrical signal. So what we have here is a piezoelectric crystal is there. Piezoelectric is a special material where if you apply, this is a crystal actually, piezoelectric crystal, I am representing here. If you apply a mechanical force here, then it will generate some electrons, and those electrons, they are got generated, it will go through the electrical circuit, and it provide the output. So that means what we have done, we have converted mechanical energy into electrical energy. Okay. This is what our transducer is there. The electrical analog and parameters. So what is the definition of transducer? Transducer converts any physical quantity into electrical signal, which is proportional to the quantum of physical quantity. So that means choice of the quartz will depend on where the linearity is there. It should be able to relate in a linear term. There should not be any non-linearity, otherwise detection will not be possible, or conversion will not be correct actually. So we will use the linear area where which is so that will help me select a quartz crystal that is available. Normally this problem doesn't come, it meets a very big range actually. So we have converted it. Now this electrical parameter voltage current is fed to the process instrumentation for further conditioning and any analysis. Okay. So we have seen we had input, we generated output electrical, and we are using it for some mechanical purpose. For bearing PHM, there are two transducers, temperature transducer and vibration transducer. So vibration or temperature, anything you put and you get electrical output, my job is done. Now I can use it in the data acquisition system, the channel for electrical signal for processing it. Okay. The other commonly known transducer based on their application are flow transducer and pressure transducer. Okay. And where it will be used? When I have got my process signal. I'm arguing out use of process parameter for prognostics and health management. In certain condition, they can be, our process parameters can be more effective. I will give one example also at the end of this lecture. Again in PHM, the transducer based on piezoelectric are used. Fine, okay. So the construction feature we have explained. Now piezoelectric effect is a crystal transform. So what translated it into current, that effect is called piezoelectric effect. In short, it means convert into mechanical form to when quartz are some special material, crystals experience physical stress that induces imbalance of charge, okay, or asymmetry we can call. Electrons concentrate in certain location, creating a negative electrical potential. This phenomena is referred as piezoelectric effect. Okay. So this is about transducer, what transducer does. Okay. Now let us see what A to D converter does actually, analog to digital converter. So we have input analog signal and digital output is going. This is nothing but a stream of 0, 1, 1, 0. Output is 0 or 1, discrete parameter. So ADC is essentially an electronic integrated circuit. Okay. Is used to convert the analog signal like current, voltage to binary zeros and ones. So signal is going in the form of 0 and 1 stream, and that if we feed it to the computer, then we can draw a graph, we can see the characteristic, how things are, vibration is varying, which are the frequencies dominating, and if those dominating frequencies I know, then I will know if whether it is an inner race failure, outer race. I am talking about mechanical component. Same thing applies for electronic component also. So in short, we are using this signal for trying to assess the characteristic, failure characteristic actually, and how far severe failure that is there. And of course, the domain knowledge will tell us which signature tells what. Then core characteristic of ADC is sampling. Sampling rate determines how fast ADC convert from analog to digital. Simple, So and then resolution. Bit resolution characteristic characterizes accuracy level for the conversion from analog to digital. How one to one they are measuring actual value and then represented value. The represented value at binary should represent the actual value. 5 volt should represent 5 volt only, not 5.2 volt or 5.1 volt. So this is a resolution, how closely our values are related. Now we have a data acquisition system, third component, that is a multiplexer. Multiplexer, it is very interesting how it generates input, based on input, how it generates output and how it is fed at the output node actually, So let us say this is a 3:1 multiplexer, they are talked like this, 3:1, 3, if it is a 4 input, then 4, 1, 4, 6 or n1. So, but at a time it does one output it generates, and what is the mechanism it happens here is multiplex. Let us see the definition. Is a digital device that can receive more than one data. There are more than one data input depending upon the capacity in terms of number of channels or configuration. So the kind of multiplexer you buy, that will tell you it is 1 channel, 2 channel, 3 channel. Of course, we will need many more channels because we are measuring many more components as part of the PHM. Then like ADC multiplexer is represented by MUX. Like ADC for analog to digital conversion, abbreviation, then or acronym for this converter, and this is MUX. Multiplexer is acronym for multiplexer. Type of MUX. There are two types of, that is frequency multiplexing and time multiplexing. It depends on your requirement. Quite possible if I am having vibration and I am working on frequency domain. There are, you know that in vibration we can have either frequency domain signature or time domain signature. Often we convert time domain signature also into frequency domain, or frequency domain into time, depending on the requirement. Why? Because I want to understand the frequency, predominant frequency for failure. So an experienced vibration specialist might say these two peaks are high, and they are saying that it is a inner race failure for the bearing. Now what we are doing? We are doing the same thing and we are atomizing those things. His experience, we know that the two peaks coming close by, and their amplitude is what our expert opinion had said, and we are getting that. So it is inner race failure. That means it is a non-intrusive technique. Without opening the bearing box, you could tell and you could prepare for the maintenance plan actually. Now operation, it is like a switch. Multiplexer, like it is like a switch. It doesn't send everything in the algorithm is built in over here. It is like a chip only, which selects only one output of n. At one point it will select only one output, and it has been programmed like this. It's not that other will not be there, but it will be done in sequence actually. Okay, so that's how the data is discharged at the output y end actually. Further, it again selects another one input, and these are the sequence 1, 0, that thing as many you have here. It will be controlling this output at the node. Further, it again select the another one input and will deliver only one output and continue like this depending on the digital configuration. So we are getting a digital configuration here. S logic operation determines which will go out. This will go out, this will go out, or this will go out. So that sequence is already has been determined on the chip in multiplexer. Now, having studied individual component, now what we try to say here, what are the broad guidelines or what we have understood. So national instrument, there is a body for at national and international level, which are the domain expert in developing the different type of instruments, and they are called national instrument. Suggests that 5 high level question should be asked before we go for details of procurement. This is a very important slide. If anyone is going for procurement of DAQ or sensors, they should understand this, and this is something like guidelines that are available here. Types of signal to be measured. Input is analog, output input is analog, output whether analog or digital. What is that output? You know, and then so what kind of signal you want in your data acquisition system? It has to be determined how many analog and how many digital signals are there. And I think in there, if you see a DAQ card, it is clearly written analog signal, data signal, digital signal, and what are the number of channels that they are having. So this is the first question one should decide based on the domain application. You know, what you want to do actually. If I want to monitor only one pump, but normally people don't do that actually, and even if I want to do that, I have to have two signals, temperature and vibration. Okay, then is signal conditioning card required? This is a big question, because otherwise I will be, if it comes as a package and I don't need it, it is unnecessary experience. At the same time, it will you can say physical matrix also will get disturbed, because when we have two signals when it is not required, signal conditioning is not required, then it will be load and liability on operation and maintenance, that you have to maintain even this card, because signal has to go through the signal conditioning card only. Okay, a typical general purpose DAQ device measures is plus minus 5 volt to plus minus 10 volt. You see, this is the range. So readily available guidance will not think much about it, and will say plus minus 5 volt to plus minus 10 volt. That is our range. Some sensor may generate signal beyond this typical capacity. In such cases, signal conditioning is required. Often, signal conditioning form part of the specification. Speed of generation of signal. This is very important. Time constant. We call it as a time constant for the signal. This refers to sampling rate. In fact, this one of the most important component, because if it is a slow signal that is going in, somewhere we compromise on the quality of measurement actually. Suppose if it is a 2 meter per second or even less or more, it impacts the whole analysis also. And what is the small change that need to be detected? It is told by resolution. What is the resolution? If I have frequency ranging from say 1 to 1000, so I should be having that kind of, but if I don't have 1 and my all frequency band is there limited to let us say 20 to 50, then that resolution should be there for that particular range. Tolerance limit for the error. This refers to the attribute accuracy. because what is actual and it should match the output also. So, in third week, I think probably we would have should get a confidence what is the data acquisition system, and then typical DAQ major characteristic what we have, performance characteristic, physical. In fact, we will be discussing performance and physical characteristic even further also. And then what we mean by sensors, probably we have discussed a lot, transducer, analog to digital and multiplexer. So, general guidelines for DQ were also discussed, So, I think we are left with the adequate information for procurement or implementation of a DAQ on my system at R&D or for implementation of prognostics and health management program. Thank you.